Hello everyone. Hopefully you hear us and see us well. So, Jacob Community is on air. Nice to see all of you here today on our webinar. And actually, the first thing I'd like to point out is to remind you that in case if you have any questions to our today's amazing speaker during his speech, please feel free to use the chat both on OrgJaCoVCommunity platform and YouTube to post your questions, notes, or even words of appreciation. By the way, in case if you hear us well, please also feel free to use the chat and post us that you are with us. Until we're waiting for your response, let me introduce you to our community a bit. So for the ones who have joined us for the first time, please don't hesitate to join us on the OrgJaCoVCommunity platform, because Jacob Community is not only about the webinars. We organize a great amount of events, as well as post the monthly digest G-News, as well as conduct monthly meeting, which is devoted to discussion of the topics of this digest, which is named G-News Talks. So this event is going to be organized soon. So please do not hesitate to join us there as well. Follow us on OrgJaCoVCommunity platform and do not miss the notification about the upcoming events. Yep, I see that YouTube chat definitely works. So that's great. Thank you. Thank you very much. Hopefully the OrgCommunity chat also works fine. So maybe I think we are ready to go. Today we are going to talk about the journey to asynchronous data processing. And let me introduce you to our amazing speaker, Ilya Khrypovich. Ilya, the floor is yours.
Thank you, Tatiana. I really appreciated to participate in this webinar. I hope my topic will be interesting for audience. So let's start about journey to async data processing in our system. I think this journey would be interesting for other systems, and I hope that all system in long-term perspective becomes asynchronous, because synchronous operations too slow. So let's move on, and let me introduce myself. My name is Ilya Khrypovich. I'm a lead software engineer at EPAM. I have master's degree in information security, about 10 years of Java. I also have AWS certificate as solution architect, and I have experience of building high-load distributed systems for different areas of business. A small introduction for today's topic. Each system one time faced with changed requirement and increasing complexity, but some requirements like response time still unchanged, and system faced with problem when it can't perform all operations in that short time of response time. And today I want to show an approach to solve this problem. Next slide. Yeah. At first, I'll talking about system evolution at all and different interfaces which are proposed to the system. Next part is async paradigm as approach to perform operations, especially business operations and operations related to interactions with other systems. Next part is transactions for async, sync, and remote calls. And the last part is service activator implementation as a solution for perform asynchronous operations. I want to remind you that you can place your questions in chat, and we will check them at the end of each part, and I'll answer all those questions. Okay, let's start from system evaluation and NFRs. NFRs usually defined on the earlier steps of system design, and architecture usually adapted to these NFRs. During system evaluation, requirements from business side usually changed, but NFRs are still unchanged. And sometimes it becomes a problem because architecture focused on initial business requirements can't perform as well as requirements are changed. Let's review three groups of NFRs. The first group are related to security, all about authentication, integrity, encryption, and other security aspects. The second group is performance. Usually this metrics related to count of user sessions, throughput rate, and response time. And the subgroup, I place here all servability metrics like reliability, maintainability, scalability, and other. From the point of view of the user, the most important metric is response time. All other NFRs are useful for business, especially the third group. It's about cost saving and something like that. The first group, security, is useful for users, but users don't care about security until something went wrong. But response time affects users immediately. And today I'll focus on the response time and how to meet this NFR. Let's move forward and scope today's discussion. You can see a sample of system that includes a green square about related to particular application and a yellow square related to some environment. We have several external services, service A, service B, message bus, two databases, and we are talking about only response time of our green service. We can't affect response time external services. We can't affect some security operations like to firewall performance, network performance, and they are out of scope of current discussion. Also, front end is out of scope too, because it's not important which application stay on front end. It could be browser or it could be web, mobile application, but response time usually counted on backend response. Okay, next slide. And as example, we will talking about a simple system for pizza delivery company. It would be Pizza Management Central or PMC. This system will cover all operations for pizza ordering, delivery, payment, and so on. and let's try to assess how a requirement can change to that system, and watch on system evolution and how business operations becomes more complex, and how to solve problems which appears during this way. Stage 0. Simple CRUD operations. For example, at that stage, PMC only can handle logits and store them in the database. No other interactions, no communications, so simple get post and simple server logic and save data into the database. Response time equal to business logic plus DB query. At that point, we can improve only performance of database. Simple, easy, nothing interesting. Stage 1. We try to increase value from the system and add additional operations and features like recommendation, order history, delivery preferences. We increase phase of calculations, fetching different data from database. So there could be performed multiple query to database, some transformations. So at that stage, we still stay in a single system, but we can improve on not only the database performance, but our architecture to reduce count of DB queries, optimize data structures, optimize some computations, and so on. Let's move forward and add external integration to our system. As example, we decided to introduce SMS notification for users. When user order pizza, user will receive the notification that we accepted this order. At scheme, you can say that we introduce service B, and response time now will include our logic, database query time, and service B response time. We can't affect service B response time. It's out of scope of our system. But it can significantly impact on overall response time of our service. And at that point, we firstly faced with potential problem with our response time NFR. When service B becomes slow, our system becomes slow, and we didn't meet NFR. And at that point, many architects, designers decided to switch to asynchronous processing. What it means? We don't want to execute service B in the same request as in time of user request. Instead of calling service B, we try to request other model to do it asynchronously. It means switch paradigm from do something to request doing something. But not all operations could be performed asynchronously or without any other feedback. To decide which operations could be performed and how to do that, I propose to use this algorithm. Let's decide that critical path is a sequence of operations that required to perform business transaction. As example of ordering pizza, let's imagine that you should pay for pizza before completes the order. In that case, payment is crucial for processing order. If payment is not performed, order shouldn't be processed. In that case, payment is a critical path. The first question that you should ask is the operation on the critical path? If no, this operation should be performed asynchronously and without any order and confirmation. As example, notification. Notification could be optional, and if user don't receive the notification, it's not important for further processing. Order will be processed, but user will have some disappointment. But it's not critical for business. For notification, we can use strategy push and forget, like push notification to some message queue and process it later. If operation is critical path, next question is how long this operation will be performed. If approximate operation time with some multiplier less than our requirement for response time, it's possible to perform this operation synchronously. As example, if payment will take about 1 second, but we have NFR for about 5 seconds for response, it sounds that payment could be performed synchronously. Because sync operation more predictable than the async operation, and architecture with synchronous calls easy to implement rather than async. On the other side, if we have a response time NFR near 5 seconds, but payment may took about 3 seconds, it's possible to fail to meet NFR, and we should perform this operation asynchronously. Next question, is the result important for user? If important, it should be something like task with states, responses, like subprocess. If no, also push and forget. Again, example with notification and payment. Payment is crucial to be sure that payment completed. If we send payment for payment system and forget about result, payment will be can be failed. Then we should react on that. At that case, we should perform something like subprocess and show user some placeholder that please wait until something going, and when payment performed, continue order. Okay, let's move forward and I'll try to answer that question on that scheme for our typical user scenario about adding pizza and order them. The first step of user scenario is adding items to cart. At that stage, we want to autosave items because if you refresh page, it will be useful if user's order come unchanged, wasn't changed. It will be simple async background iteration because it's not critical if you missed an item. Push and forget, good option for that. Next step, submit order. When user submits order, we should save order in the database and respond to user with some confirmation. It should be synchronous operation because it is critical path and will not time consuming. Next step, perform payment. User try to pay, and we will start some async process to maintain the status of order. When operation will complete, we will change the order status. It is critical path and time consuming, and result is required, and it should be task creation. And the last step, notification. We will send notification to user, and for that it's not a critical path, and push and forget strategy is also applicable here. So another example, another view. Common, I think, operation cases for push and forget and subprocess. For push and forget, usually it's something related to reporting, audit, notification, simple operations that could be performed in background, and usually these operations performed by other part of system and haven't impact to user experience. A typical operation for subprocess is long operations like uploading, downloading data. During this process, we are interested into the states, progress, some error appeared during this process, and it's impossible to implement with push and forget strategy. Next slide illustrates more complex architecture of our pizza management system with more complex steps of user journey. And here I want to emphasize two steps related to payment. They are critical for business and should be performed with creation task, but they are time consuming, and implementing these steps with synchronous calls may be may cause problems with meeting NFRs related to response time. So before we are going to transactions, do we have any questions in chat?
Actually, we have some interesting comments rather than questions. It's been mentioned that according to the slide which you've shared about the non-functional requirements, there is quite a long list of them. And actually, guys have mentioned that it seems like the most of them are quite functional requirements, in fact. So in case if we consider in general, how they work and what they mean. So that's why, for example, Sam Newman in his book Building Microservices calls them cross-functional requirements. So I think that's an interesting point of view. By the way, thanks from us as well for sharing, for referencing this book. So guys, if you're interested in more details, please feel free to find the name in the OrgJaCoVCommunity platform chat. Yep. What do you think about that in general? So about whether the requirements are actually non-functional or cross-functional. So from your standpoint.
So it's quite a discussable question, mostly about terminology. Also, we have all functional, non-functional, cross-functional requirements as requirements. But from point of view, for example, microservices, some of them becomes functional because these requirements becomes more critical for business, and business decided to say that it's functional requirements to emphasize the importance of this requirement. I think so. But when we're talking about not microservices, it's not cross-functional requirements. So if we're talking about system as a big system that combine multiple microservices inside of that, the requirements for each microservice is not requirement for the system. But in scope of system, we can say that the requirement about response time for microservice becomes functional requirement inside the system, because system become malfunction if this requirement broken. Sounds like that.
I see. Thank you. Thank you very much. I think this is interesting point for considering it while architecture, while working on architecture. So of different systems and considering different requirements which should be defined. Yep, I see one more question, by the way. What is advantage of async? Is common way without async when of multiple clients are connecting? So a bit like complex structure of the question, but yeah. Anyway, so which advantage in general of async processing, and is there a common way handle situations when multiple clients are connecting?
So multiple clients, it's not a problem when we're talking about multiple clients. We're talking about multiple requests, multiple threads, virtual threads, but we are talking about response time of one particular request. It's not important how much clients we have. It's horizontal scaling. We can increase count of pods and parallel requests for them to increase throughput and count of simultaneous user sessions. But when our single request consume a lot of time, the only way to perform this request more quickly and is extract some synchronous operations to async and respond to user with some content, with some response in time. We can't ask user waiting for response. We can respond that, okay, your request is acquired, we will process it, but we should respond in time. And at that scenario, question to weird because it's not about count of users, it's about single user.
I see. I see. Actually, just a short note, and we are going to move forward. I see one more question in the chat, but let me leave it to the Q&A session. It's not directly related to the topic, so to the moment where we are right now in the presentation. So just a short side note from a chat. I think it depends basically on the project phase. So whether the requirements are non-functional or cross-functional. Initially, the product side always want just the business logic to be implemented, and after that they start to complain that the system is slow. Sounds quite like true story, but anyway, this is something which we should, at least as developers, architects, consider from the very beginning in order to be ready for that. Ilya, I think we can move forward with your presentation.
Okay,
thank you.
Let's continue with transactions. The first step of transactions, when we return to our picture of stage 0, when we have only a database, single request response, and one query to database, it's simplest way for transaction is ACID transactions in a relation database. Simple to implement, supported out of the box by all relational database and frameworks. Additionally, you can use some logs, optimistic lock-ins to avoid concurrent notification, and so on. If we have only a single database, it's a solution. But if we increase the complexity and add another service, we can see that there will be two transactions in service A and service B. As example, we want to send notification on user request, we open transaction, store order in database, then we call service B, send notification, then after successful commit sending notification, we commit transaction. For sync operation, it works, yeah, but we also have some issues related with that. What happens? Transaction boundaries. We really have two transactions. First, big transaction covered with green square. It includes order and send notification, and yellow transaction related to notification. What can go wrong? First, order validation failed. We roll back whole transaction. No notification sent. User can resubmit order, and it's okay. Second scenario, when we store order, but notification failed, then we roll back transaction. User also can resubmit order, and it's okay. Nothing wrong happened. And third scenario is not good, because we sent notification, but after a successful send notification, we failed to commit transaction. In that case, a user will receive an error that order is not submitted, but user will receive an SMS that order is accepted. And it is best scenario for business. How to avoid it? The first solution is using some message bus to exclude notification servers from transaction. We'll push a message to message broker, for example, to Kafka, and responds the user that it's okay. order accepted, and then user will receive an SMS notification. It's a typical solution for many systems in relation to notifications. What pluses we have there? It's simple to implement. Reduce response time because we exclude response time of notification servers. Only response from message broker, but it's usually fast response. Cons. We need a message broker. If we have message broker on landscape, it's an option. If we haven't, it's a point to discussion or evaluation. Do we really need message broker? Another aspect is confirmation of sending. This strategy is push and forget. We push message and no more care about response. If we need acceptance that the notification service really send notification, it's not a solution for us. Next solution splits transaction in two and simply call notification service after committing order transaction. This scheme seems not quite correct because response will continue includes response time of notification service. Yeah, but we solve the issue with transactions because one transaction performed and order completed, and another transaction with sent notification could failed and notification becomes optional. Similar to previous scenario without confirmation from notification service. And the third scenario on which I want to focus it, and the topic of today's discussion is isolate transaction boundaries with service activator pattern. For that strategy, in transaction of saving order, we also create a task for notification. We store order and create task in the same transaction. Creation of task can't fail because it's a simple operation with writing records into the database. And then another process, named service activator, fetch task from table and send notification through notification service. Then task stays updated and we can view the result. Possible fail scenarios, again, we can store order, but notification wasn't sent. It could be handled via some incident management. As a second scenario, notification could be sent twice if transaction of service activator failed, but notification sent. It's also acceptable for the most cases. Yeah. Before we proceed, what about question in chat?
Yep, we do have some questions and notes. So the first note, I really like it, so I need to voice it. Let's imagine that you're waiting for a doctor in a long queue. You can do nothing or you can learn something new. Synchronous asynchronous is about personal way to utilize available resources, either your life or CPU. So yep, I totally agree. This is about the right utilization of available resources. So it's really important to use as more as possible of them, but considering all other factors, for example, that sometimes you just not need to be too tired. So actually, one more point. This is the question about the schema with message broker. Not sure how message broker will help with transactions. Are we talking about distributed transaction with broker support in it?
I especially haven't focused on message broker transactions because it's a very discussable again topic, and we can spend a lot of time to discuss how to properly implement transactions, for example, in Kafka, and how to combine transaction in database and transaction in Kafka. And in general, with message broker, we have another system to integrate. Simply we replace notification service with message broker, and transaction in message broker becomes a replacement of transaction in notification service. But usually the call of message broker is quite fast, and we can perform these operations synchronously. I mean that also call to message broker usually quite fail safe, and its reliability of message broker higher than our services. But we also rely on the message broker reliability, and designing a system with messaging require additional evaluation of risks related to failure of message broker, or duplication of messages, and other aspects related to messaging. So it's out of scope of service activator, and I suggest service activator as an alternative for message broker. In conclusion of the of today's speech, I'll provide a simple comparison between message brokers and service activator pattern, and I think we will continue to discuss that.
Okay, great. I think let's then move forward to this exact point. Yeah, by the way, one more question, I think. How does the request flow start from service activator after transaction completion from order service? So, yeah, I agree. This is the point where, so whether we use like push or pull approach, so how do we connect them?
It's a topic of the section of the implementation.
So then let's move on.
Yeah, let's move on. And again, the problem in general, service A needs to perform some operation using service B, and this operation should be performed asynchronously and transactionally. For that purpose, service A creates a task for service B, then service B fetch this task from outbox table and perform the operation. Service activator works like watcher. It's completely pull approach. Service activator watch on new requests in the table and call service B. Related to question. Back. So, what type of task could be operated by service activator? There are two types of tasks. It's independent tasks and dependent tasks. Independent task means that tasks not connected to each other and could be performed in any order, in parallel, and this is it's similar to messaging in general, because messaging focus on independent task and independent result of performing the task. For example, resizing images. It doesn't matter in which order we perform processing. All images eventually will be resized. And the other task is dependent. When we should perform a task related to single entity one by one. For example, building business audit based on entity difference. When we send not full snapshots but diffs, and for that case, order is important because changed one field twice should be resulted in for the last state of the field, but not intermediate state. And our implementation will focus on that task too. We implement this pattern to address three scenarios. It's processing data from Kafka topic. For that scenario, we have requirement to ordering of process. For example, we process hierarchical dictionaries, and children could be delivered via Kafka before parent arrives. And at that case, we shouldn't hang and be able to process next records and return to the previous when parent record arrives. For that purpose, we introduce a specific pattern with source activator. We consume data from Kafka into a database table, then process them grouping by key. It allows us to perform parallel processing for different keys and ordering process for records related to single key. Another scenario is asynchronous tasks for everything. It's maximum optimization. Is true source activator pattern. When we should perform something asynchronously, we create task, then job fetch the tasks and call appropriate services. And the third scenario is message bus implementation. It's an implementation of messaging based on a database table. What we are aimed to perform that as a competitor for Service Activator was Spring Integration, for example, that could perform this messaging in memory, but it's crucial for us to be resilient to application crashes. If application crashes, all queues in memory goes out, and messages won't process it in future. With Service Activator pattern, all messages stored in database, and application restart is safe for us. Which challenges we faced? As I mentioned, we consume hierarchical data. We also challenged with huge record tables, about 20 million records per table. but we solve this issue, and it works fine. We introduce a library to use it in our different part of project and different projects. We introduce strategies for recoverable and not recoverable errors when processing. We implement JTry with backoff. It means async task that call external system is reliable to availability of the system. If system is unavailable, we will retry the task in future. We optimized queries for huge tables, and all operations are transactional. It means that task performed transactionally. And main results, as I mentioned, operations transactional. We can consume a stream with unordered items and reorder in them in the database. It's easy to troubleshoot some issues related to data consuming and processing. In comparison with messaging, it's easy to check status of the particular record in database and fix some errors or reprocess records. We can customize strategies. We can perform processing in multi-threads by partitions, and also support multiple instances, which can increase throughput of the system. And as I mentioned above, the comparison with messaging. The typical messaging like Kafka or RabbitMQ or Amazon SQS say that streaming is near real time. It's also discussable because through real-time streaming, it's discussable. But in comparison with messaging, service activator is not real-time, but it's near real-time because we use micro batches for fetch records from the database. And the time of processing could be adjusted with job duration and frequency of job launch. Next, batch processing. As I mentioned, we have micro batches, and yes, it's batching. For messaging, batch processing depends on broker. For many, in general, messaging also supports batch processing. For error handling, we have different approach in comparison with messaging. Usually, a messaging system use approach of DLQ or data letter queue, and if we want to support possibility to postpone processing of some records until, for example, parent record arrives, it requires complex logic to group that messages into a particular DLQ, and also it could be solved with different topics in Kafka, but in general, it's more complex rather than our solution with service activator when we can simple group it by ID in database. Next point, manual processing. We can simple change state in database, and job automatically fetch this record on the next iteration. For messaging, we only can repush message, but usually it will push in the enter queue, and for large lag, it's impossible to push message forward. Next, topic related to the prioritizing. We can implement priority with fetch strategy. For messaging, its only way to prioritize messages is using multiple topics. I mean, we have several topics with priorities and fetch data from all of them for a single consumer. And firstly, we process more prioritized topics, then let's prioritize it. Or we also can prioritize messages inside a single batch. And the last point is transactions. Transactional works on database, a relational database, and transaction is out of box. For messaging, as we discussed, transactions implemented differently in different brokers. Sometimes it's difficult to roll back transactions, and I think transactions is pain point for messaging. We should go with other solutions like distributed transactions or some pattern like Saga with messaging. So that's all from my side. If you want to ask me something, it's time for questions.
Thank you. Thank you very much for the great presentation and for a truly important topic. As for the questions, I see one question in the chat, which is for a long time already there. So let me voice it. But this is about like more low-level details. What do you think about Project Loom? Is it a competitor for OrgJava or Reactor?
So Project Loom is about threads, yeah, and I think it's it's competitor for Rix or some or Reactor because they solve the same issue, but they solve issue from other side, and I think time show us the winner. I think that it's not truly competitor. It's a tool. Project Loom is a tool we can use that tool to solve parallel requests like Reactor. But in general, we can use Project Loom under the hood of Reactor. And it's a good option because Reactor solves many other issues related to asynchronous processing and reactive programming that Project Loom doesn't support. Project Loom is simple tool to virtual trading. It's not a serial bullet to solve issues related to reactivity.
I see. Thank you. Thank you very much. One more question. I switch order a bit. This approach was used before Kafka and RabbitMQ became popular, right? This is about the service activator.
Service activator is not a new paradigm. It's not a new idea, but history like a spiral, and the old ideas becomes more popular through the time and have new life with new challenges. Messaging solve many issues that faced with service activator. So service activator is overkill if you don't want transactions. If you don't need transactions, you can simply use push and forget strategy. Push message to message broker and forget about it. Nice.
Yep. Actually, I think the next question, and for now it's the last one in the chat, is like a great sum up to the whole discussion. Could you recommend any sources to deep dive into this topic?
Oh, I can't find it on the top of my mind. I think the current state of technologies could answer this question better than me. You can use Google or ChatGPT and ask them about the activator and have a lot of information about that.
Actually, in case if we like want to post something and find some interesting links for you guys, they will be placed below the talk recording on the Weir community platform in the comments section. So please do not hesitate to revisit it, as well as it will contain the presentation, and yeah, definitely the recording will be posted. And for the ones who are with us right now, and for the ones who are going to watch us as a recording, guys, please do not hesitate to use Weir community platform functionality to say thank you using the thank you button and rate the talk on Weir community platform in case if you like our content. Yep, I see that guys continue to reply to each other in the chat, but we're a bit out of time. So thank you guys for staying with us. Thank you, Ilya, for the great presentation. And please follow us on Weir community platform and join more our interesting events, webinars, and podcasts. Thank you very much. Bye, guys.
Thank you.